in his presentation. Thank you.
Thanks, Jordan. Hopefully everyone can hear me well. And as you can see here from the introduction, this is an introduction to indoor air quality, really designed around commercial real estate and touches on some industrial facilities. This is actually part of a broader program that is designed for LEED existing buildings, designed around the management of indoor air quality in existing buildings, obviously. So I shrunk down the presentation to try to fit it into the timelines we have. So as you can see here, here's some of the learning objectives, and this is the true starting point of part one. It's really just to increase your knowledge of indoor air quality, recognize the different contaminants, all the way through diagnosing and solving indoor air quality programs. We're going to touch on how indoor air quality and energy efficiency aren't mutually exclusive, and a final part about managing indoor air quality in buildings. So really to start off with, we have the fundamentals of indoor air quality. It comes down to what is it? Well, we all know we're all breathing it. We're probably inside buildings, and if you're not inside of a building right now, I'm jealous of you. And why is this so important? Why is the quality of the air important? Well, one big reason is it's public perception. There have been articles like these you see in front of you on the screen. People correlate poor indoor air quality to some great buildings, and there's no real reason for it. So people want to combat it, but also there are serious contaminants that are in commercial real estate and other types of buildings that we all need to be aware of. How to manage those risks is really where the art of indoor air quality comes into play. So some of the big fundamentals are, within a building we have various contaminants, such as chemicals. We're building buildings tighter than we used to. We used to have operable windows. Very rarely see that nowadays. People are perpetually trying to reduce the ventilation rates in buildings. Sometimes deferred maintenance has to occur, etc. These all can affect, obviously, the indoor air quality. And when you're talking about an indoor air quality management plan or a management program, it's really designed to combat those issues or the perceptions that are there of those issues. And good indoor air quality can improve the marketability of a building, has been documented through many studies, reduce absences of work, increase productivity, which is really where the benefit of good indoor air quality and documenting, which is the key part of it, documenting good indoor air quality occurs. And also reducing liabilities and minimizing complaints. Some of the occupants' symptoms that people have from poor indoor air quality, we have all experienced them through if you have allergies, etc. They can be acute, chronic, or just be something as minor as discomfort. And when I talk about productivity, poor indoor air quality, as you can see here from these studies, can have a huge issue regarding the finances of a building. And some of the biggest, most common topics regarding with indoor air quality are building-associated illnesses, sick building syndrome. You might get headaches or whatever the various complaints can be that don't have to be the full-fledged sick building syndrome. But it can either brand a building as poor, or it can also just affect the individual worker or the individual group or team and really have large effects back to those financial issues we just discussed. One of the big issues with indoor air quality is, which you'll keep hearing me chime in about, is it's multifaceted. One issue may cause a different effect on different people. So the most common issue we see in indoor air quality from an overall indoor air quality issue is the indoor climate. Temperature, humidity. There's actually a 60 Minutes snapshot a couple of years ago that said the new Cold War, and it was actually the battle of the office thermostat. And that can cause many issues. As you can see right here, a mislocated thermostat is something that can be easily fixed, but can cause huge issues and perception issues, and not just having comfort. You see, there's a space heater. It's things that building management have to counter in these beautiful modern buildings all the time. So thermal issues are a large part. Many other things affect the indoor air quality, though. Ventilation, various pollutant sources such as print rooms, etc. Outdoor sources of pollution are a big thing. Sometimes you don't want to bring in a lot of outdoor air. Let's say you're in a brownfield redevelopment per se, or the most polluted city in the world, I believe, is in Mongolia because they still use coal. Well, you might not want to have large amounts of outdoor air. You might not want to have a lot of more filtration. And there's different aspects of which you can battle through those different issues. But ignoring them isn't the solution. So you have airflow patterns also, and then the various filtration systems. If you don't have enough filtration, you can cause certain issues. So that's really just a brief overview. And if you notice, I'm moving pretty fast. This is a pretty lengthy presentation, but hopefully it'll get across the point, the overview point of the importance of it and how to manage a lot of these aspects. So recognizing and managing indoor air quality contaminants is really the next big step. So there's different types of pollutants, as you can see listed here, all the way from tobacco smoke through just dusts or cleaning agents like chemicals, etc. And here's just what I did was I made a short list of and consolidated them. But here's a sampling of some indoor contaminants. Printers, photocopiers, you can have dust, etc. coming off of those things. And if you don't have the proper exhaust or ventilation or pressurizations, those can cause indoor air quality concerns or issues that can have large effects on back to that productivity. And here's some just snapshots that we've seen through the years, things like closed dampers, dirty fan coils, etc. So these are sort of the gruesome photos that we see that have direct effects on the indoor air quality. They can be easily preventable through proper maintenance. Some other sources, mold. If you have floods, dry them quickly, and the EPA has great documentation on that. Vehicular sources, loading docks, not having trucks idling while you're sitting there, or monitor the carbon dioxide in garages. So there's various other easily managed protocols that can ensure that the indoor air quality is acceptable. And those should be documented and highlighted to people. And that's a reoccurring source, as you'll see throughout this, is the documentation and the communication. Recognizing and managing some outdoor source pollutions. It's a big issue. The ambient outdoor air is especially when you're talking with the Army Corps, where you have locations all throughout the world. I personally work with the World Bank and other organizations that are international, and a lot of people take for granted the complexity and the excellent systems we have in many locations. But when you start getting into maybe not third world countries, but other locations where the indoor air quality may not be as extensively managed, the outdoor air quality may not be as extensively managed through the use of open coal, etc. Properly filtering and managing the outdoor air is a huge issue. Here's a prime example of outdoor air introduction system that hasn't been maintained properly. Getting rid of birds' nests, etc. in the outdoor air can obviously, by not fixing the issue, have a large effect on the indoor air quality and the various contaminants and diseases that could run rampant from birds and other random animals. But this is something we see fairly common in large cities across the country and across the world. It's a lack of maintenance ability, but doing preventative maintenance now can really cause issues in the future. And those, again, are just some sample snapshots. Indoor air quality control strategies. This is where where we're going to start getting into the real crux. We all know what the main issues are, but how do you control the strategies of the pollutant indoors? So the big part is policies and execution of the policies. I've seen some of those beautiful policies and beautiful language, if you can call it that, on various projects, but the lack of execution of them, or the lack of the execution of the intent of them, is really where we run into major issues. So the first thing we're going to talk about is remodeling and renovation, sustaining the comfort and well-being of the construction workers. And not just the workers, especially if you're doing tenant build-out work, it's the issues of the other workers that are going around. And actually, if you see here, it says Healthy Buildings IAQ Management Program. It should actually state the I-BEAM protocols. I-BEAM has various protocols that's produced through the EPA, but there are easy ways to manage these pollutant sources. And when you're talking about remodeling, one of the big things is painting. A lot of paints have moved through to low VOC and no VOC issues, but you still see large VOC levels in certain paints. And the one thing I try to harp with people is sort of have to think of it as it's a quantity issue, the amount of painting that's going on, or the timing of the painting. Because you might be using low and no VOC paints, but the perception's there. And that's what you really have to combat by having those management policies and management programs. So you really want to try to paint during unoccupied hours, keeping lid on paint containers, keeping those paint containers when not in use in a common area. Ventilate properly, and avoid spraying, obviously, if possible, if you are painting during occupied hours. But here's a prime example of what we see all the time, or what we try to prevent all the time, of painting during occupied hours, which isn't a big deal necessarily. But if you notice here, the exhaust system is doing its job, it's trying to exhaust. But there is, if you don't have a proper management of your return air and your supply air, well, you're actually just spreading the common return through the air handling units into these other offices. And it's something as simple as this that can be prevented, that could really have a large effect on the indoor air quality and the perception of the indoor air quality that you're trying to manage. Another big aspect is pest control, using an integrated pest management plan where possible. The big part about this is avoid using random spraying and spraying during occupied hours, especially when people are walking in and out of buildings. It happens all the time. But you really want to try to do this during unoccupied hours if you have to use that. But also try to focus on using baits, traps, and more eco-friendly ways of managing it, of your pest issue. Just because, number one, obviously the poor perception of having pests in your building, like we all know what they are. But also the chemicals that may off-gas and the issues that those cause, that we'll talk about in a little bit. Shipping and receiving, like I mentioned before, it's a very common issue regarding the indoor air quality of a building when you have idling trucks, UPS trucks. People are just dropping into the receiving areas and just letting their car idle. Depending where, or truck idle, depending where the outdoor air intakes are, the pressurization of the building, etc., you can cause a lot of issues. Pressurization in shipping and receiving areas is usually a large issue, mainly because you have a big hole in the side of the building, which is a good thing. You have to bring products in, but by having a big hole, if you don't have proper HVAC setup, you can create a very large negative space. It's also very common to have that issue in any entrance into the building or main egress into the building. But by front doors, you run into this a lot, where you have a poor pressurization. And that lets in various contaminants from the street level, from the loading dock, and can cause many other issues. Smoking is a pretty big issue, as we can all attest to, when it comes to the indoor air quality of a building. Smoking in buildings is pretty much banned across the board. But when you start getting into foreign countries, it's not. So managing the various smoking policies and managing the location of smoking and smoking in the buildings, etc., is a big part. Just because without that, and without things like in the lead credits that say you have to have a 25-foot have a smoking area 25 feet away from any egress point, can be an issue. You have to try to find that location, and away from any outdoor air supply into the building. And there are ways to designate a smoking room. You can design a smoking room, and that's fine. Airports have them all the time. But it's just having a properly designed smoking room is the key part. And the key issue with communication, especially when designing buildings. Setting that up properly is a major issue and should not be taken lightly. Another big aspect of managing the future indoor air quality and the indoor air quality of the building is managing the moisture and molds within the building. Maintaining a proper relative humidity, less than 65%. A big thing that developers are starting to move to throughout the building process is actually managing the potential for mold and moisture issues during construction. Actually writing it into contracts where they have random site visits by an independent contractor to confirm the building conditions throughout the months, or after any major moisture or rain event. And the premise behind that is to stop things before they start. So if you have the elevator shafts set up with drywall, but you don't have the building sealed up, which is a very common thing, especially when we're talking about a core of a building. But if those do get wet through, for whatever reasons, having a documented removal of it or management of those moisture issues will prevent issues in the future when the building is completed. Now we're going to start talking a little bit about the driving forces of pollutants. Where are they coming from? And there's various ways pollutants can come through. Wind in the building, the doors open, pressurization issues, stack effects. Buildings can act like big chimneys in that the air will move up. So if you have somebody smoking in a hallway, for example, somebody might be smelling that 10, 12, 13 floors later, just based on how it's working. Another effect in a building is what's called a piston effect. It's when elevators are moving up and down and actually moving the air because there are large cabs moving up and down. So you can take a contaminant that is from, let's say, a laboratory on a low floor. It can easily be transported up and it can easily be transported down. So again, proper pressurization and HVAC maintenance and design can prevent all of these issues. It's just having those issues brought to everyone's attention early in the development process and or in the management of the building. So here are some examples of airflow pathways. And I chose outdoor air as a sample. Like I said, this presentation is a lot longer. It actually has, like, I'd say about 10 of these little diagrams, but I wanted to shrink it so we can fit into the time frame. So I think outdoor air is the most interesting one usually for people, mainly because people don't, well, in the past, people and engineers didn't really think of other buildings because they didn't have the capabilities to model a building, let's say, in the 1950s. We didn't have those capabilities. So designing around other buildings, designing around other cities, using computational fluid dynamics, using these various other tools that we can have to properly manage the outdoor airflow and prevailing winds can really prevent a lot of issues. Still today, we recommend to people simple solutions to things like this, having exhausts and supplies right next to each other. There's easy solutions to that to make sure things are working properly. And or from an HVAC point of view. But also, the indoor air quality also revolves around radon. It's a hot button issue, especially in the mid-Atlantic. You get into the Blue Ridge and up into New York and New Jersey, for example, where they do have some radon issues occasionally in the ground. And it's maintaining that and monitoring that, which can prevent a lot of things. If you have crawl spaces, if you have substructures within a building, knowing that radon's an issue, and if you do have an issue from it, manage it. Have a radon mitigation system, etc. So a big part now we're going to start getting into is ventilation. Ventilation does solve a lot of problems. When in doubt, it's sort of a ventilation. That doesn't necessarily mean increased indoor air quality. It means proper ventilation. Proper amounts of ventilation that ASHRAE recommends. So when we're talking about ventilation, we're talking about exhausting pollutants from a source and introducing non-contaminated air, I guess is the best way to put it. So you have the dilution of ventilation, which is you have various sources, various people, you have various contaminants within a space, printers, copiers, etc. Diluting the air and diluting those contaminants so that we don't have an issue. And when we're talking about, well, how do we do that? Well, we do that most commonly through HVAC systems that through the years have become more complex and better. So when you're talking about HVAC system and the challenges of indoor air quality, this is how you dilute and you ventilate these buildings. And you properly distribute the air, maintaining thermal comfort. A big part is managing your energy use and along with keeping proper indoor air quality, and they're not mutually exclusive. And preventative maintenance, which can easily affect the energy of the building. For the HVAC components of the building and their relevance to indoor air quality, the biggest one is our cooling towers. They are perfect incubators and perfect vehicles for growing legionnaires disease and other microbial and bacterial growth. And their locations in regards to outdoor air intakes and locations of the building as a whole, and the design and piping throughout the HVAC system is a huge part of indoor air quality, and it's probably the most important part. Legionnaires disease is a documented killer. It's a lot of the other issues with indoor air quality come to comfort and the perceptions and the management of them, but Legionnaire's disease is the biggest thing. Actually, ASHRAE is reviewing a new standard, it's called ASHRAE 188, about managing Legionnaire's disease and bacterial growth within cooling towers and the plumbing system as a whole. And when I say as a whole, you're talking about hot water taps, hot water tanks, etc. So that's really the big thing from an ASHRAE standpoint that's coming out and has a direct correlation to the indoor air quality of a building. And you're talking about boilers is another prime example, confirming that you have proper exhaust, confirming that you have proper valving and design so that you don't have carbon monoxide poisoning issues, so you don't have these various issues that can easily have huge detrimental effects to the indoor air quality. And we're talking about ventilation. It's the main standard that everyone uses is ASHRAE 62. I referenced 2007, but there's 2009, and there's various updates that continually be managed. This really right now is the baseline of LEED and other building codes, etc. Obviously, I'm assuming most people know who ASHRAE is, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This really sets up to confirm the amount of outdoor air that a building or a space should have, the various critical zones, and when I say critical zones, like cafes or conference rooms or auditoriums. And the determination of that amount of outdoor air that each space needs is set up on a square footage and a number of full-time occupants or possible occupants in that space. And each space type, such as a classroom, has a different requirement on a square footage and individual basis than a office space or a cafe. So it's wide-ranging, it's comprehensive, and it's an industry standard. But this is really where the management of indoor air quality comes from. Another ASHRAE standard would be the management of temperature and humidity. Back to what I talked about really early in the presentation was moisture. You don't want to have your moisture getting out of hand. You want to keep your humidities below 65%. You want to keep your temperatures at common office spaces. And what ASHRAE did was, through ASHRAE 55, they came up with temperatures, and they came up with ASHRAE 52, they came up with humidity levels to baselines of buildings. And as you can see here, when you're talking about temperatures, it's common office temperature, but these are guidelines that everyone's held to so that we can have a comfortable workspace. On to the importance of housekeeping. Preventative maintenance can, like it says, prevent these issues from occurring. And a lot of this can occur during the design of a building and the setup of a new building. Creating policies and housekeeping policies and maintenance policies as a building's being turned over and developed is a thing that we notice that gets lost a lot of times. I work on a lot of new construction projects and a lot of existing building projects. And it still boggles my mind the lack of communication on a turnover. I guess it's one of the reasons I always preach to people to do enhanced commissioning. Like, it's always good to have an engineer come back randomly. And enhanced commissioning, for example, has a direct correlation to the indoor air quality, confirming that things are operating properly to those design standards. Just today, as an anecdote, I got a phone call from somebody from a tenant build-out, and we had done a project on a focused indoor air quality study on. And they hadn't done enhanced commissioning, hadn't done any commissioning on the tenant build-out. And when we were on site, we noticed one little issue. the complaints they kept on having about dust and in the space itself. And it turns out that on the return air ducts during the construction process, they put really good zip filters on them, which was great, but they never took those off. So the filters were caked with various dust and dirt, etc. The ducts were very clean. They were doing a great job, but they weren't actually creating a proper system. So you could just imagine if eventually this got clogged and there was this dust sitting around, people were having these various complaints. And I said, that's why I would recommend commissioning your systems and having somebody independent walk through your systems to make sure they're cleared after turnover. But some simple solutions like that and preventative maintenance and documented housekeeping can occur. So we're talking preventative maintenance. You're having a PM program, an extensive one, having engineers go through the building and the space. We're talking about, let's say, a new construction project. Having an independent engineer or having the team itself, the design team, walk through the space to confirm, yes, this is what we have, and discussing it with the turnover team who will be managing and living in that building. And once they're in that building, having a documented program of every so months changing filters, etc., and adhering, and that's the most important part, obviously, to any policy, is adhering to said policy. And this is the most important way to prevent any IAQ issues. It's common sense. It's managing what you have. Some big parts of a PM system are the administration methods, having a record and a reminder program to say, okay, this is every how many months we do this. And this is what the USGBC actually requires for IAQ prerequisite 1, which is documenting the intent of Ashworth 62 and not just measuring the outdoor air and saying, yes, you're bringing in enough outdoor air and you're managing your system properly, but also document your PM records. So LEED existing buildings requires that. And you'd be amazed actually on how hard it is for us to get those records sometimes. And it sort of scares me a little bit that people can't find them, can't manage them, etc. But that's why it's so important. And in conjunction with that, that's where I-BEAM also comes in. They actually have housekeeping and maintenance modules. And a big thing, if you've heard it mentioned a couple of times, is the EPA's I-BEAM program, which we'll go into a little bit of detail later. But it's a good baseline program and recommendations on how to manage the indoor air quality. And keeping these files and records and having the master equipment list are huge, not just for, let's say, eventually going through a retro commissioning program and maintaining the energy of the building and maintaining the systems and the life cycle of the systems, but also about the indoor air quality of the systems, knowing where you may have dead legs in your water system, knowing where you have your shut-off valves, and if you have the proper shut-off valves in the building, etc., so we don't have backflow of cooling tower water into your system, for example. These are all, having these records and documentation that are accurate are hugely important to maintaining and managing the indoor air quality. And here's some examples of preventative maintenance tasks. So when you're talking about outdoor air intakes or louvers, documenting that you have no pollutant sources within 25 feet. It's amazing what gets added to a building and taken off of a building. So knowing those documentations, and actually Ashworth 62 states that if there's any major change in tenancy or activity in the building, you should reevaluate the amount of outdoor air you're bringing into the building. And that also goes back into those maintenance programs and the maintenance tasks. They're living, breathing documents, just as buildings are. They get created, and then they last for a long time. The buildings don't go away. They usually stay for a very long time. So maintaining these things and having various maintenance tasks and knowing what you have is a huge part. Another anecdote was just last week I got a phone call from somebody who was very scared by a refrigerant leak they were having. I said, well, okay. And they actually had gone through the LEED process in this building, and don't worry, it's not local to DC. It's in the United States, though. And I said, yeah, we don't have this refrigerant. And I said, what do you mean you don't have the refrigerant? Well, so here's our, what's called, for LEED existing buildings, EA Prerequisite 3, which is the management of refrigeration. You're supposed to document all the refrigerant in the building. And they thought they did, but a tenant actually had a whole subsystem that no one really knew about from years ago that actually caused a leak. And things like that of knowing what you have in your building and managing it. And that's sometimes a hard thing in large buildings and even small buildings, but it's huge to do. Checking the filter fits perpetually is another big issue. Manage these things, and things change in buildings. So taking proactive action can prevent a lot of these issues. Now on to housekeeping. So housekeeping, daylight cleaning and various issues like that are great things, and it's fantastic. But we also have to take into account the management of not just the perception of those, but the management the housekeeping staff and team is doing. So using using green chemicals, using different types of vacuums, etc., can prevent pollution from self-pollution, I guess you could say, of the cleaning systems. And while they're cleaning, don't stir up more dust and dirt, but actually remove it. Using like I said, low chemical products, green seals out there, and these various other organizations that certify green products, and they're now really readily available and should be used and can be used in many instances. So maintaining, negotiating, and training the housekeeping staff is a huge part about maintaining the indoor air quality of the space, obviously. Now let's say you actually do have an indoor air quality issue, either at building turnover, or during the construction of a tenant build-out, etc. And diagnosing and solving the problems are a large part of overall indoor air quality management of a building and the perception of a building. And sorry about my arrow location. It does not look right there, does it? The biggest part about is recognizing what the issue is. At least a couple times a year I'll get a phone call and I say, that is not where you should be calling me, you should be calling the first responders. Happens a couple times a year, which always is amazing. Determine if it's truly an emergency. Hey, we have a couple thousand pounds of Freon leak. Okay, that's an emergency. Call your first responders. You just don't want a consultant to help you solve that problem. You want to take it as a health safety issue. And again, I can't stress that enough. Knowing the proper plan of attack. And some things aren't an emergency. If somebody has perceived sniffles, etc. of a space, well, that's great also. But you don't need to call the first responders for that necessarily. So manage what's called an emergency and have a determination and a plan of what is an emergency and what isn't an emergency. First part is to take actions to protect people and property. Then determine if it's building related. And if it is, characterize it. Find out what's going on. A lot of times, a lot of people want to go run and do samples and run indoor air quality tests. And we can test for this and we can test for that. And that's not necessarily the right solution. Taking a step back and taking a calm look at the situation, a lot of indoor air quality issues can be resolved without taking a pump or any kinds of indoor air quality samples at all. And when I talk about identifying emergency, hazardous material spills, black water floods, those are things that you just don't want to. If you don't know what black water is, it's not clean water. We'll put it that way. It's the exact opposite of clean water. You don't have to call first responders necessarily for that, but you have to call remediation companies. And again, like I said, people will call me up about black water floods all the time. We'll say, well, has it been remediated? Get the remediation teams out there first, then we should talk. Gas leaks, combustion issues, if you have very widespread breathing issues, etc., or legionnaires disease or tuberculosis issues, or if anyone who's watching the news in Los Angeles, if you have black water coming out of the tap of a hotel, that is an issue. It was very widely reported. If anyone doesn't know what that is, look up. There's a hotel actually in California that had major water issues because a woman sadly had died and fallen into their water supply and was actually in the water tank on the roof. That's a large issue. First responders. Of course, that's the extreme. But now off the emergency aspect of managing indoor air quality complaint, into the issues with indoor air quality complaints, the overlapping symptomatology of them. What may cause me, Chris Ashworth, to cough and have wheezing and feel terrible based on my allergies, Lindsay Pruitt may feel fine. will have no issues at all in the exact same space. But what may bother me, what won't bother me, will bother her. And that's really the issue of it. If you notice here, a lot of these issues here can be caused by the same parts. A sinus headache can be caused by molds. Rash can be caused by molds. So trying to narrow those issues down and narrow those contaminants down, those possible causes down, is the difficult issue. And you see here, any of these symptoms can be caused by the same type of contaminants. And this happens a lot throughout the indoor air quality process. So the big part is to take a step back and take a building systems approach. Say, what do we have? What has our maintenance been? Have we had any changes in tenancy and occupancy and activities, etc.? And once you determine that, you'll really be able to narrow down your investigation. Oh, 5 people just brought in new plants. Okay, are they maintaining the hygiene of the plants? Are they allowed to have those plants in our office technically? Why do they have them, etc.? And narrow down those investigations. Once you've really exhausted that logical step, those steps, then you can start coming into the measurement of the space, taking temperature and humidity measurements, airflow, pressurization, can be measured easily by these, let's say, smoke tubes. A big thing is light. We're all staring at computers nowadays. Taking a step back and looking at that person who has an issue, looking at their office. Well, is that computer screen behind a window? Various issues like that. Checking the carbon dioxide for the ventilation. ASHRAE standards usually, I believe, off the top of my head, is 700 parts per million greater than outside. So checking that to see if there actually is proper ventilation within a space. And the biggest part is you can test for pretty much anything under the sun. It's trying to narrow down the most common issues, such as possible airborne molds, volatile organic compounds, and looking at the activities that were occurring in the space or are occurring in the space that could be causing those indoor air quality concerns. And after you really diagnose those previous issues, that's when you want to contact a professional or a firm to assist you or outside help within your organization to try to diagnose the issue through testing, etc. Testing should be sort of a last resort. You want to increase the communication and documentation aspects, and that's really where you can solve some issues. Now on to the indoor air quality and energy efficiency of it combination. So one of the big things to highlight here when you're talking about indoor air quality and energy is that ASHRAE has standards for ventilation, and they're really designed not just to have way too much air just for trivial sake. It's designed for a reason that way. And when you're talking about the design of a modern mechanical system, you have core zones tend to receive less air than perimeter zones. Economizers on VAV systems are usually advantageous, mainly because you're going to have the ability to provide extra outdoor air into the space without having an effect on the energy use. VAVs with fixed outside air dampers and no economizers are sometimes really poorly designed systems. They poor outdoor air delivery, and there's no real energy benefit to them. So you really have to look at the system you have before trying to save energy through possibly compromising indoor air quality. But maintaining the system is a huge aspect of it. Properly cleaning coils, managing thermostats properly, having proper control systems can really save 5 to 15%. Really doing a thorough retro commissioning of a building is a huge part and can save you tons of money, while maintaining and improving the indoor air quality of the system. Another aspect would be free cooling, setting up your system so that you can, if you're in a temperate climate, so that you can bring in extra outdoor air without, again, any extra energy use. Some systems are designed so you have nighttime pre-cooling, or as a way to reduce demand on the and load shedding. There's various ways where you can save energy and also not have an effect at all on the indoor air quality. One part is supplier temperature resets. So you can reduce that will have a huge effect in reducing your chiller energy. It may increase your fan speed, your fan energy use, but it actually, because you have to move more air, but the energy savings will, a lot of times greatly offset that. So you don't notice, you actually get a benefit from an energy standpoint. Something that's becoming more and more popular is carbon dioxide controlled ventilation. Having those in the proper locations are a huge part. And through ASHRAE 62, there are two paths of compliance. I've only talked previously on the testing methodology of saying, and the measurement of the outdoor air coming in. It's actually what's called the indoor air quality, or the indoor environmental quality methodology. We were testing for certain contaminants. The most popular contaminant is carbon dioxide, since we all expel it. I've been talking for 40 minutes, and obviously in my office, CO2 levels have probably risen. That's what we all expel. So managing a space per that is a way that really maintains indoor air quality and can save you energy. And then reducing light usage during unoccupied hours. See it all the time. If no one's there, we'll turn off the lights. We're talking about the indoor environmental quality of the space. So you're talking about lighting, ergonomics, etc., and maintaining and managing those various aspects can save you energy easily. And sometimes there's a perception out there when designing or building a building that the indoor air, or managing a building, the indoor air quality is totally incompatible with operational measures, etc. So you want to reduce the outside air below standards, or reduce the HVAC runtime. And studies have shown that the loss, first of all, in productivity of, you don't see the benefit there for the worker, the employee. Yes, you may save energy, let's say, by reducing the outdoor air, by closing the outdoor air dampers. But what are you really saving? You're probably saving on the coil side, because your automation system's running those fans based on the pressure set points within the automation system. So you're just recirculating that air. So you're not really saving a lot of energy there necessarily. You're saving some, in theory, on the cooling coils or the preheat coils. And there is reducing temperature humidity set points. Again, not wise, just because you can cause various other maintenance issues to not just the equipment, but also to the building itself. And here's actually a little link that has that you can go to that is designed to make energy professionals a little more aware of the pitfalls of ignoring indoor air quality concerns in a space. And here's actually the final section of managing for the indoor air quality. And it looks like I'm going to get in under the 4 o'clock, so we'll have a couple minutes for questions if anyone has them. So really, when you're talking about managing the indoor air quality or the indoor environmental quality management of the building, at any program, it's all about assigning an IAQ manager. And this is right from I-BEAM standards. You want to have a stakeholder in this. If you don't have a stakeholder, as we all know, things can go awry because no one's there to take responsibility. The training of not just staff and the engineers, but also the supervisors, the management team, the asset managers, having a common baseline of knowledge that everyone can build upon is a key part in maintaining good indoor air quality, and not just one building or portfolios of buildings or designing buildings. It's extremely wise. Having a baseline audit at some point in time, either at turnover or during a random month or random years throughout the occupancy. I know the GSA does this, I think, like every 4 years. Don't quote me on that. But various indoor air quality baseline audits based on tenancy changes is recommended through ASHRAE 62. It's good practice to see where you stand at that moment in time based on your building's issues and your building's activities. Having written plans and protocols, and having a communications program, bringing it to the attention that you know about this and you're maintaining it and you're managing it. Having a specific procedure for responding to indoor air quality complaints, like I was touching on before, know what an emergency is and know what a possible nuisance, I guess for lack of a better term, is. And then market for and budget for an indoor air quality program. All these tasks obviously aren't free, that we just talked about. They take time, and time is money. So have a plan of attack for that, so that you're not surprised by it in various budgets at turnover of a building or even at the maintenance and the managing of the building. And speaking of that, organizing the building records. There's various computer programs out there. I mean, I have a picture of a binder, but there's various computer programs that can manage these. And there are forms that are free that we have through the EPA through I-BEAM that are designed to track these issues, track complaints that are for operating maintenance plans and schedules that are just basic charts that if you fill them in, you manage them, it's amazing what you can see and what you can accomplish and see trends throughout the building's lifetime. And to follow up again, responding to air quality complaints, it's not just being hyper reactive. It's doing all these previous tasks that we just talked about and having these records right here. Having that baseline of information is how you can attack and solve complaints and communicate them confidently that you're doing what you can. So when you're talking about principles, address promptly, don't let people hang out there, but also follow up with their activities. Communication resolves a lot of indoor air quality issues. It's seeing people take concern and then communicating that logically and with proper documentation. And that is really where I end. It looks like I have 9 minutes left at the 4 o'clock deadline I believe I had. So anyone has any questions or anything like that? I tried to wrap it up early, so meet Lindsay's
thank you,
timeline.
Chris. We do have 2 questions from a guest, Mr. Jonathan Houston. His first question is, what are the most common contributors to poor IAQ that you have seen?
The most common things are temperature, humidity, and either volatile organic compounds, which are pretty much omnipresent. They're everywhere. That's what makes our furnitures, these VOCs. I'd say mold, just because the management of floods and moisture issues, mold was here before all of us were alive as individuals, and it'll be here after us. And it's the maintaining and managing of those moisture issues that can easily be resolved, but are very prevalent. Comparing the mold levels of certain types of mold in comparison to what's going outside. So it's really like a comparison. And when you notice these different types of mold inside that aren't located from the outside air, that's where you can determine if you have an issue. And it's pretty prevalent when you notice in floods,
and one more question. He has asked for you to describe methods to help prevent the piston effect.
With the piston effect with elevators, it's a difficult thing. Some of it cannot be prevented that I know of from a system approach, mainly because you do have these moving through the buildings. The biggest thing I think when you're looking at it is the activities going on in certain locations. If you have a laboratory or you have a print shop, which is very common, print shops producing tons of dust a lot of times, using various chemicals, you want to have those under proper pressurization to other locations. I used to work for Pfizer in a clean room, and that's the prime example of proper pressurization. Or a surgical suite is another one. You don't want your surgical suite to be under a negative pressure for obvious reasons, the various contaminants and the various pathogens and bloodborne pathogens that can be moved through the air. So that's managing the pressure of the building and those individual spaces is huge. If you can get your whole building under a positive pressure, so you're not perpetually sucking in, you can go a long way to resolving pressure issues.
Okay, we have another question from Donald Archibald. He thinks that it is important to mention that Army bases have industrial hygienists that are a great source of information for IAQ problems. So thank you, Donald, for sharing that information.
Absolutely, and the EPA and the GSA have great resources for various government organizations and a lot of great online documentation. There's actually what's called the See I-BEAM. It's the Interagency Committee on Indoor Air Quality, and they have you can call in for free to this. Phil Jalbert runs it. They have quarterly meetings. You can log in online. You can do various things with them, and they have various discussion points of what different agencies and groups are doing, and it's free to the public, free to you guys, and it's a great resource. And he's a great guy, and would hopefully steer you in the proper way. He works for the EPA, so you have a lot of great resources within yourselves.
I did have a question, Jordan. Chris, this is Lindsay. I was going to ask you, we're looking at a measurement and verification process where the Corps would validate a certain performance level expectation of a facility. How long after the building, a new construction facility is turned over, do you actually do the independent assessment? And is that something that there's a particular time, or is it by climate zone or facility type that weigh into consideration on how long after the building's turned over that you would actually do that assessment?
All of the above, really. It depends on when the occupancy of the building's occurring. It also depends on the usage and the commissioning structure of the building. You don't want to sit there and take a baseline as somebody's still finalizing their functional and performance tests, for obviously reasons we all know. So taking that step back and having a separate group come through once that's been set up is what I would recommend. So really looking at the occupancy of it and the finalization of the turnover of the building, if that makes sense. What I've usually seen is it's usually a couple months after occupancy, just because the final functional performance testing is getting wrapped up, the final checkout items and checklist items are getting finished up, and that's really when an audit like
Great.
that
I
would
really
occur.
appreciate your time. And for everybody on the line, Chris has volunteered to present this to us. Chris works with Healthy Buildings. Chris, do you want to talk a little bit about the mission of your organization?
Sure. So we are been around for 30 years. I've been with the company 9 years, and we are an environmental consulting firm that we're on the GSA schedule, and we do everything from indoor environmental quality projects, such as indoor air quality audits, complaint resolutions, etc. We do commissioning, retro commissioning, energy audits, corporate sustainability management, lead management, and various activities. So water management that we either work for the government on, or we work for commercial real estate, commercial developers, property management groups, etc. Across the country, we have offices overseas too, in Australia,
Great. Well, really
England,
yeah.
Ireland.
And thanks for taking the time to do this.
Try to keep it concise.
And present this aspect for us. We appreciate it. And for everybody else on the line, we will have the recording available on our website. If you guys have any questions or comments, in the lower left-hand note section, I've put down my email address and as well as Jordan's email address. And we will have another webinar, same time, next Tuesday at 3 o'clock. Thank everyone.